All right, so I don't like density. Density confuses me, so I'm going to attempt this problem here to see if I can figure this out. All right, so this question reads, what is the mass in grams of 1 gallon of water? Okay, and a gallon is a unit of volume, right? It's something that is taking up space in a three-dimensional space. And we know the density of water is 1.00 grams per milliliter. So already I don't like this problem because we're working with, the imperial system gallons and 2 metric conversions here. So, but that's okay. So we are actually given a bunch of conversion factors in the problem, which is going to help us out, okay? So this is a mass problem. I don't know the formula for mass, but what I do know is the formula for density equals mass over volume, all right? So what I can do is, how do we isolate the m? If this was just an equation, let's multiply this side by v, because it's in the denominator, and bring the v on the other side. So now we have our mass calculation. Mass equals density times volume. Awesome. So the mass is what we're looking for. We have our volume. So mass equals, let's put our density first, 1.00 grams per milliliter times our volume, which is 1.00 gallons. All right. So density here, volume here. Now, we can't multiply. What we want to do here is cancel our volume units, right? We want to be able to cancel milliliters with gallons, but we can't do that. And you can see this problem taking shape, and this is the reason I make sure to put milliliters under gram, and I put a little 1 under the gallons. Because our final units, mass is in grams, and it even says in the problem, what is the mass in grams? That's our only remaining unit in this dimensional analysis problem, right? So we know this is set up correctly out of the gate, which is good to know. So let's convert gallons, let's get gallons to milliliters, and then we can rewrite this and find our answer, all right? So how many gallons in milliliters, or gallons to milliliters? And we're going from a large number, a large unit, to a small unit. So many milliliters, many little guys are going to fill in this big guy, all right? So let's keep that in mind. All right, so they give us some conversions here. They're not giving us directly milliliters to gallons. What they are giving us is liters to quarts and quarts to gallons. All right, so let's do that. So let's do 1 gallon They're also giving us 1 gram of water equals 1 milliliter of water. I don't know that we need that for this, but let's figure it out and see if we can get the answer depending on what we know makes sense. So 1 gallon. So what's our, working backwards here, we can go to quarts, and we're going to put gallons under here, 1 gallon. And remember, we're putting that under there because we want to, as we go, cross off our units. And they have to be, as we're multiplying, different in the numerator and the denominator. So we're going to put 4 quarts here. All right, we're going to keep moving. We know quarts will go down here. We know that 1.057 quarts in 1 liter. Nice. Quarts are going to cancel. Looks like we need 1 more here. 1 liter equals 1,000 milliliters. So that's going to cancel. Awesome. So this whole little problem is going to convert gallons to milliliters. That's pretty cool. And then we should be able to plug that back into our original problem. So let's do this calculation. The first thing is just 1 time, so we can even skip gallons. So we're just going to do 4 quarts times 1 over 1.057 times 1,000 milliliters. So we'll double check that. 1 gallon, which we don't really need to multiply this by 1. 4 quarts times 1 over 1.057 times 1,000. Our answer is 3,784. How many significant figures are we working with here? It looks like 3. But we're going to keep this full calculation just so we have it written down. Milliliters. So 1 gallon equals that many milliliters. Makes sense. A lot of milliliters are going to equal 1 gallon. So now we should be able to, if I'm doing this correctly, we should be able to plug this into our original mass problem, which is mass equals 1 gram per milliliter. I guess that's maybe why they gave us this here, but we already, I don't know, times, not 1 gallon anymore, and this is what this original equation here is what I'm looking at. Remember, this is our density. Our volume, now we have in milliliters, which is 3784.295 milliliters. Now look what we're canceling out. We're canceling out our milliliter unit and our milliliter unit. This is a 1. And our answer will now be represented in grams. Okay, so we're just multiplying 1. It's nice and easy. 1 times this. This is actually our answer here. 3784.295. And also, look, 1 gram equals 1 milliliter. So this, milliliters and grams, are interchangeable. So that's pretty cool. So our answer, hopefully, is 3784.295 grams, or potentially in 3 significant figures. 1, 2, 3780 grams. All right, let's pray and hope that that's what we got in the textbook. So 3780 grams. Okay, it always freaks you out when this is in scientific notation, but look what we have. Times 10 to the third. 1, 2, 3, 3780 grams. And we can even double check. If we put ours in scientific notation, 3.7 times 10. 1, 2, 3. Whoops. 1, 2, 3 times 10 to the third. All right, and there you have it. Again, always refreshing to be able to get the right answer here. So, awesome.